Hmm.
Histogram.
Pi. Histogram you said.
Scatter.
Box.
Scatter. And box plot. Yeah. Box plot. Okay. Then you should be able to tell me for what kind of variables we use these graphs. What are their
Bar chart.
primary uses? Yeah.
Bar chart for categorical and numerical data.
It can be used for categorical as well as
Numerical.
numerical data. And
And
if it is categorical data, it gives you the n or percentage, by the way. Percentage. If it is a numerical data, then the mean or other. If you have a pie graph, where we it is
Only for categorical.
categorical data, and it gives us the n of percentage. What is the purpose of histogram?
checks numerical.
Histograms are used for numerical data.
For the distribution.
Yeah, and it is used to check for the distribution. Check for distribution. Distribution of the data. Is it skewed or not? Histogram is checking whether your data is symmetrical as it is here, or whether it is skewed as it is here. This is skewed. Skewed to right or left, this one?
Right.
Right, thank you. If the long tail is on the right, we call it a right skewed data. Okay, then the scatter diagram.
It's numerical.
It's for two numerical data. Two numerical data. And this gives us the correlation. It is used to check for the correlation. Correlation between two numerical data. But it can be also sometimes one numerical and one ordinal data. Box plot.
Numerical.
Also to display numerical data, and it gives us valuable information about
outliers.
Outliers. What else?
And extreme values.
5 or 6, yeah, extremes.
Median also.
Median also, yeah. Median. And minimum, maximum.
Yeah.
Minimum, maximum. What else?
Percentage.
Percentiles, yeah. 25th and 75th percentile. Very good. Thank you for helping me to remind what we discussed last time. And what do we do with the outliers? If we have outliers, is it good for doing statistics, outliers or extreme values?
Outliers?
Outliers. It is difficult to work with outliers, we said last time, as you might remember. It is difficult if we have extremes and outliers. It is difficult to conduct some biostatistical analysis, especially the parametric tests. Parametric and non-parametric. We have two types of hypothesis tests.
And if we have outliers, we can only use non-parametric tests.
Yeah, if you have outliers or extreme values, too many, not only one or two outliers does not influence, but if you have too many outliers causing this kind of distribution, then we have to use the non-parametric test, but actually we would prefer to use the parametric test because these are, later I will mention you, these parametric tests are taking into consideration, into account, all the participants, while the extreme value, the non-parametric tests, they are based on ranks. Non-parametric tests are based on rank orders, rank tests. These we call also the rank tests, the non-parametric tests. Okay, so far so good. Now, let me discard this. Clean. Now I want to discuss with you. It's time to discuss tables. And the next session, today we will discuss the average, doing more statistics. What about tables? Here I have a small presentation for you. Okay. I usually don't have presentations, but this time I decided I will have a presentation to make it better to display the information. There are, now I'm going to give you some rules to prepare tables. First, I selected from an article a poor table, a table which I can call a bad table or a table which you should not have. Which you should, and this is from a real study, unfortunately. I have a. Could you help me to find out what is poor here? What is not good in this? Is there something which is disturbing you from the table? As a novice students, you should be able to.
Maybe
What?
maybe gender.
Gender, yeah, it can be sex or gender. That's not a big issue. Mostly we call it sex. Because sex,
Is it poor thing? Like
sex refers to genetical or phenotypical. There is a difference between sex and gender, genetic or phenotype. You know what is phenotype?
yes.
The outside appearance. But while gender is something else. What is gender? Gender is the role given to a person. A person can be genetically male, but he feels like a female, and he may call himself, I am a female. There are these terms of transsexuals. So mostly in scientific, therefore, mostly in scientific papers, we speak of sex because it is what it is. It is a genetical definition. So what do you see as are there some issues which you would not do, which you would do different? Some points. If you would have been drawing this table. Okay. Let's look one by one. We have sex. These are the different variables, by the way. Sex is a categorical variable, right?
Yes.
Categorical, ordinal or nominal?
Nominal.
Nominal.
Yeah, that's good. Thank you. These are my students. They are learning it. Yeah. Race or ethnicity is also a categorical
Nominal.
nominal variable. Age,
H
Numerical.
numerical.
Continuous.
Numerical.
Numerical
Correct.
or it can be also presented at numerical discrete. H. Then what we have here? We have something else. What is this?
Marriage status.
Very
Marital status. But the title is missing. Yeah? There should be here marital status. See? Marital with one R or double R? I forgot how to write it.
2R.
Marital status. Okay. Double R you mean, huh? Okay. Marital status. Single. What else do we have? Multiple partner fertility. Multiple partner fertility, single partner fertility. Why this is bold, black, while the others are normal font? This is capital. It's strange, isn't it? And there is a star here. If you have a star, you should have the explanation of that star. If you have any symbols, any abbreviations, any symbols or abbreviations should be explained. So, as a rule, we can say that any symbols or abbreviations should be explained. Okay. So this is a mistake. This is not in accordance with the rest of the table. Here we have bold and capital letters, while in the rest of the table we see normal fonts. Then we have educational attainment, less than, high school, college. What kind of data is this? Variable is this?
Categorical.
Categorical.
This is categorical.
Nominal.
Categorical, nominal.
Ordinal.
Ordinal. Ordinal.
Some say it's ordinal. Yes, of course it is ordinal. Ordinal. Categorical, ordinal. Okay. And we have lastly another variable, employment, which is categorical and nominal. Okay. And here he made another mistake by underlining these options. Underlining. Why he underlined, I don't know. If you underline this, why don't you underline the others? You should have a homogeneous appearance in the table. Homogeneous. Anything else you could criticize? We could criticize the vertical lines. Vertical lines. We don't want vertical lines. Not welcome. Can I write not welcome? Not welcome. These vertical lines are not welcome. Vertical lines, okay? Instead, we want to see horizontal lines like this. There should be horizontal lines. But the vertical lines should be deleted, of course. Okay. And another one here. This would be a better appearance. What else? If you give a percentage, is it okay to give it as it is displayed here, 93%, 7% only? Yeah. Can you understand from this table how many males are there or how many females are there?
No.
No.
No? Okay, then this is also another mistake. N and percentage. always go together. And always, if you categorical data, always and percentage. From the solely presenting, giving the percentage, you cannot understand how many people are there. You should give also the n. For example, here we have how many? Let's say 14. And 93 multiplied by 2 is, okay, let me forget about it. We don't know the n, and the percentage should be given here, okay? The n should be besides the percentage. Another issue is the decimals. Did he present any decimals? No. No decimals. By the way, here the educational attainment 25. Is this what, an n or a percentage?
Mm,
We don't know.
yes.
It's probably 40, 60, 80, 90. It's probably n. This is probably n. While because he also didn't mention the percentage here. This is n. And while on the others variables, he mentioned the percentage. Here, he decided to give the n. That's also not okay. You have to give also always n and percentage. And you should mention on the top of the table what you give. This is n and percentage. And then you should have n. Let's say n is something, I don't know what here. And percentage n. And in brackets 7 point something. Usually we decide to give, if it is 0, 7.0, we prefer to give one decimal for the percentages. One decimal for the percent, mostly. It can have, of course, it can be also more than one, or mostly one decimal is enough. Yes, and what about this numerical variable? We have one numerical variable here. The mean age is 36. This is also not okay. Mean should be given with
Percentage.
Percentage is for the categorical data. If you have a categorical data, always give n and percentage. If you have numerical data, as it is here, it should be given, we will discuss in the next session. Mean, as it is here, mean, that's correct, no problem with the mean. And standard deviation, mean, should be either. This we will discuss next session. Mean plus minus standard deviation or median and range. Okay. He has given here mean and range, which is not appropriate. Mean is given and then range, that's not appropriate. I will mention in the next session why. So this is another problem. And the decimal is missing. Usually we prefer two decimals for numerical data. Okay, and this is range. There is no problem with the range, but here again we have regular script and bold script. It should be homogeneous. Yeah. What else is missing? In any table, we should have the table name, a title. Table, this is table 1, for example. We should explain what it is, the table. And below the table, we should have the legend. Table legend. Okay. Then that's all what I mentioned already. If you are performing descriptive statistics, it is a good way to present your data with the tables. Let me repeat. When I say biostatistics, we understand data, collection of data, and here we have the different data types, numerical, categorical data types. Then we have analysis that we will discuss. We have the different hypothesis tests, etc. And presentation, presenting data. When you present your data, you do either descriptive data presentation or hypothesis tests, H0, H1, hypothesis tests. So for presenting data in a descriptive way, it is very useful to use to have the tables. You should, of course, know if you have 2, 3, or more than 3 variables. If you have one variable, you just can give it as a frequencies of that variable. But if you have 2 variables, then you should have one variable in the columns and the other variable in the rows. For example, if I want to display sex as a table, then I should mention sex, male, female. Then I should give the n and the percentage. That's okay. But if I have 2 variables, such as I have, let's say, sex, and I want to see smoking status, smoking positives, smoking negatives, okay, and then I can have a different table look. Like in the columns, I have the smoking status, and in the rows, I have the sex again, males and females. And here, of course, n and percentage, and another n and percentage, both for males and females. And we are not forced to have a table always. We may have sometimes also a figure, of course. Question mark here. Sometimes they present only significant results, but this is a bias, of course. It's if you have significant or non-significant in any scientific study, you may have significant results or non-significant. Both can be presented as tables. All this I mentioned in the first slide. Title, you should have a title. You should cite your table in the text, by the way. In the text, while you're writing the text, you should mention table 1 presents this, table 2 presents that. And you should be consistent, whether you use comma or full stop. Let me see in this example here. We don't have any comma or full stops, but if you're using English style, then you should have full stop, isn't it? To have a decimal separator. In Turkey, for example, they use the comma. In other countries, it may be different. In Germany, they use comma for a decimal separator. The fonts should be consistent as well. Always use the same fonts. Variable names, abbreviations should be explained on the bottom of the table as a legend. And number of decimals, as I said, for percentages, 1 decimal. For means, usually we have 2 decimals. We don't want to have vertical lines, mismatch of bold in italics. There might be exceptions, but usually. And unnecessary or inconsistent decimals we should not have. If you, by the way, if you present in a table a statistical value, such as p value, p is equal to, let's say, 0.001, you should have 3 decimals. It's not appropriate to say p below 0.5. Here you have only 1 decimal. Also, the same applies for t values, for chi-square values, or for the other statistical parameters, descriptions. You should have always 3 decimals. Means as 2 and percentage as 1 decimal. And we prefer to use the 0 in the top, in the beginning of any numerical expression. Instead of point, this is a scientific expression, of course, but in medicine, they use this 0 point or comma, depending on your country. You may have 0 point or 0.9. Yeah, this one here is an example of a good table. Let's have a look at it. There is a table ID, title of the table, and it can be bold, as it is here. It should be enough explanatory title. Then we have here column variables, estimated, positive and significant, negative and significant. So the groups, let's say, these are the groups. Group variable, which is categorical. And here we have the outcome variables, such as demographic variables, forehead, male, age. Age is numerical. Male, female is categorical. Age squared, and so on. And at the bottom we have explanations of the letters of the abbreviations. Here we have A, and there is the explanation of A. If you would have an abbreviation here, then also it should be mentioned in the bottom of the table, at the bottom of the table. Lastly, before stopping this session, let me do a table using the SPSS. I hope you all could manage installing SPSS into your computers. And I suggest you to do what I'm demonstrating here, because the session is recorded. You can view it and try to do the same tables. The data set, if you want, I can give you. We have in the SPSS different ways of preparing tables, but the easiest and the most commonly used way is this here: analyze, custom tables, and here they have the custom table option. This is a very user-friendly interface. You can drag and drop your variables into the rows or columns. If I have sex is what? It's a categorical variable, categorical and nominal variable. You see, if I have it here, and it should be mentioned as, if I have this only and click OK, you should say, Professor, this was not correct. Huh? Male, female, yeah, good table, but only count N, only N. on n is not appropriate. We should have what? We should have additionally, we should see that with the categorical variable, we should see, besides the count, we should see the percentage, column percentage. Okay, apply and okay. Now it's better. Male 236 people and the percentage is 59.9, 54.9. If I have more than one variable, analyze custom tables here. If I have more than one variable, such as sex and let's say smoking status of the different groups, then I can drop my second variable to the column. Now I have smoking status, yes and no, and compared between males and females. So simple is this. Yeah, you see? Now I have. And then when I'm going to present this as a table to my audiences, it's suggested to delete the vertical lines and leave the horizontal lines only. Otherwise, this is a very good table. Of course, if your audiences are English, if you're submitting to an English article, then you should use instead of comma. Okay. This is enough, I think, for tables, presenting data with tables. Shall I give a break?
Yes, let's
Okay.
take 10 minutes break.
10 minutes. Okay, after 10 minutes, we meet at 5:50.
Yep.
See you later.
Time is up, Professor. Should be covered.
I don't know. Is 10 minutes past?
Yep.
No, 10 minutes. 10 minutes past. We can start. The average. The average. This is the title of this session. I always repeat it, but it is because I want you to have it in your heart. Statistics is about collecting data, analyzing it, and presenting your data. Collecting, analyzing, and presenting. When you present your data, if it is categorical data is presented as n and percentage. Already mentioned that. If you presenting your categorical data, you have to give the number of people, number of participants, and percentage. Sample size and percentage. One, omitting one is not okay. If you have numerical data, numerical variable, then you have to give the average and the spread. Let me explain you why. Let us say, just imagine, I don't know, I didn't see you by face. You are 18, 20 people in your class. 18, 20 people in your class, 24. And I asked somebody to go in your class and measure the weights, numerical variable. Measure the weight of the students. He comes to your class and he measures the weights in kilograms. Okay, and he comes back to me and he reports. Student number 1 is 60 kg. Student number 2 is 59. Student number 3 is 73, and so on. But giving me all the names would be very difficult for the person, and also for me to, if it is a long list, to understand 20, 24. How many are you in the class? I don't know. Remember. So it's difficult from the raw data. This is the raw data. From the raw data, it is difficult to figure out and understand what's going on in this class. What's the appearance? What's the real picture of the weight? Therefore, we summarize it. We summarize the data. Summarization can be what? The person can come to me, my assistant, for example. If I ask, go and measure the weights, and he comes back and he reports me the mean. Says the mean weight is, let's say, 66.7 kilogram. The mean. Is that enough? If I don't see all this data is not there in front of me. I only see that on this figure, 66.7 kilogram. That's not enough, of course, because with this 66.7, I will have an image. Let's make a histogram. What was the name of this graph? This is a histogram. Histogram. And this histogram, if the mean is 66.7, this is the mean, 66.7. It means that most of the people in the class are somewhere here, but I don't know the tails of the distribution. These are the tails. Huh? This is the central area, and these are the tails. I don't know. I don't have any opinion about the tails. Without knowing the tails, it's not possible to have a complete picture of a numerical variable. I should have also some information about the tails, the minimum, the maximums, for example. Therefore, with the mean, we present the usually the standard deviation, right? Standard deviation. This is what we call the spread. This tails, where are the tails going to, is the spread of your data. And this is the average or the central tendency, central appearance or central tendency or average. Okay. Therefore, as a rule, if you have a numerical data, you always give the average, which can be mean, which can be also something else, mean, and plus and the spread. We have a numerical data. We should always present, as in categorical data, we present n and percentage. In a numerical data, we should give information, provide information about the mean or the average and the spread, the central area of our distribution and how it is spread. Now, let me tell you something. If you have, I guess in your class, you are all similar weights. There is not too much deviation, too much outliers. But if there are outliers, if there are too many outliers, your distribution will be skewed, right? Your distribution will look something like this, skewed, because you have some, let's say, some sumo wrestlers, some very high, 160 kilogram, 150 kilogram, and again, the most of you, the class is around 66 point something, but there are overweight or extreme or outliers in your class. Now, if we have outliers and we measure the weight will be moving towards the right, towards the extreme values, towards the outliers. It will look like in a case of extreme values, if I have some outliers in your class and I measure the weight, it will be reported, let's say, as the mean can be, in this case, the mean can be, let's say, 75. But actually, most of your the members in your class are around 60 something. But when it is reported to me 75, I will have a wrong image of your class, just because of a few, 3, 4, 5, I don't know how many, a few outliers may deviate your mean from the actual number to the right, and it will be misleading in this case. All this speech I make to trying to explain you, if you have outliers, your mean is not reliable anymore. Instead of the mean, therefore, we decide to give the what? The median. Okay. Instead of mean, we give them the median. The median is more reliable for what kind of data? For skewed data. Let me show you this with the SPSS. Here I have some data. Wait. I do analyze descriptive statistics. Among the frequencies section heading, I have statistics. And look to the statistics, you see central tendency and dispersion. Central tendency is about the central area, giving us information about the central area. And dispersion is giving us information about the tails. Any questions so far? Okay. If I want to display information about the central tendency, I can give the mean, the median, the mode, and the sum. So please remember, these four, the median, mean, median, mode, and the sum, are parameters showing the central of my histogram, the central distribution, the central area. While these are the others here, which we will discuss in the next session. Okay, I don't show them now. These are used to give an information about the dispersion, about the tails, information about they provide information about the tails. Let us click continue and okay. And just unclick this. Okay, you see here the mean is 74, the median is 72. The mean is more than the median. Why is the mean larger than the median? Just let's have a fictitious data here. This is, let's say, your class. Your class, you are 10 students. I will make it 10 because it will be making 10 students. And these are your weights, 72, 78. There may be some students 80 kilograms, some 89, some again 65, some girls were 40, 48, 51. Okay, we have in your class now, we have 10 students, and these are the weights of the students. Let me analyze it. Analyze descriptive statistics, frequencies of this variable, and mean and median. Okay. You see the mean and median, they are very similar, 65.4 and 65.5. Very similar. Now, if I order this sort ascending, if I order this, you see in the middle, the midline of 10 is 5, between 5 and 6. Between 5 and 6, we have 65.5. Okay, this is the median. The median value is the midpoint when you order your data. The midpoint. If you have a odd number, of course, you should. It's easy. If you have 11 people, then the mid would be 6. But if you have 10, as it is here, an even number, then the median will be the midpoint between the two people in the middle, 65.5. Let me copy this. Oops. Copy this. Paste it here. And I remove these 3 students in your class. I remove them. And I put there some heavyweight people, 160, 180, 175. What will happen to the mean now? The mean will be increasing, but actually the majority of the students, the 7 students, still having weights around 60 or 50 something. If I do this analysis for if I check the mean, again here. Okay. Mean and medians are checked. Unclick this frequency tables. You see, the mean is now 92.2. This is, of course, misleading because the majority of the students still around 65. What happened to the median? Look to the median. The median did not change. It is still 65.5. Why it didn't change? Because the midpoint is still, if you order the data, it will be still these two people, participant number 5 and 6, case number 5 and 6, and the midpoint between these two is 65.5. So the median is not affected. The median is more stable if you have skewed data. If we draw the histograms of these two variables, it will be more visual for you, more visible for you. Histogram. Display normal curve. And histogram of this first variable. Display normal curve. Apply. Histogram of this first variable. You see, it is quite symmetrical. The bell-shaped curve here is quite symmetrical. If I do it again, graphs, chart builder, for the other variable, for the skewed variable, for the scenario with the extremes, with the heavyweights, you see that the heavyweights on the right have made this curve to be skewed to the right, and the mean in this case has increased to 92. Although still in the class, I have the majority of the students. I have weights. They have weights between 40 and 72. So these three extreme values or outliers, they have skewed my data to the right. That's why if you have skewed data, extreme values, the mean, as a rule, the mean is not reliable. Instead of the mean, you should use the median. Is it clear, or do you have any questions so far? I will go to the book and try to show it also in the book. Okay. So book. Yeah. The objective here is to have feelings for your data. It is difficult to have a feeling. You want to understand what is my numerical data, what did I measure. Therefore, to describe your data, it is good to have the average, to show the average, and the spread too. The average showing the central area, and the spread showing the tails of your distribution. Tails of your distribution. For the average, in order to show the average, the most frequently used parameter is the mean or the arithmetic mean. We can call it also the is very simple. I don't explain it to you again. It is, high school information, adding each person, each measurement together and dividing by the total. On the other hand, the median is the midpoint. If you order the variable, the cases, the median is the midpoint between the minimum and the maximum. An odd number, you add the 2 in the middle and divide by 2. if it is an odd number. If it is an even number, it is the one in the middle. The mode is not used so frequently. The mode is the one occurring most frequently in a data set, but this we don't use. Just you need it maybe just for theoretical purposes. Otherwise, in the statistical analysis or scientific arena, we don't use the mode so frequently. Then the last two parameters used, the mean and the weighted mean. I should explain you a little bit more about the geometric mean and the weighted mean. Geometric mean is for taking the logarithm of each variable. Taking the logarithm of each variable. Just have a look at this data again. In this example here, we have a person who is 40 kilogram, another one 48, 51, etc. And here we have the extreme ones, 180. There's a big gap between the one who is 40 and the one who is 180. There is a big difference between these two. What do we do in the geometrical mean? We take the logarithm of each variable. It is this session we will have again, don't worry, about the logarithmic transformation. Just do it rapidly. I take the logarithm of each case, and they look all 2, but I should show the decimals, of course. 2 decimals. Okay, as you see, I had a person with the weight 40 kilogram, and I have taken the logarithm. Now it has become 1.6. The logarithm of 40 on a base of 10 is 1.6. Then look to this person who was 180. There was a difference of 140 kilograms between this heavy person and this light person. But when you take the logarithm, the difference has decreased pretty much. It is now the person with the least weight is 1.6 and has a logarithmic transformation of 1.6, while the one with the most heavy is 2.2. So the difference has decreased. Therefore, if you have this data, you can, since the gaps between each individuals has decreased, it will be easier to work with it because you don't have any more the extreme values. You see, you don't have extremes anymore with the logarithmic transformation. It's a good method to be used for, and now I can take the mean of this logarithmic transformed data and take the mean, descriptive statistics. Here is the mean now. I have the mean 1.89 and the median, mean and median, they're very, very similar now. Both are 1.8. I can take the mean and then take the anti-log, which you should know from high school, taking the anti-log. And by this way, I can have the display or present the geometrical mean. The geometrical mean is sometimes used in scientific data. Let us see. Just to give you an insight. Let's go to the PubMed, okay, and say logarithmic transformation, logarithmic, is it with H or without H, logarithmic transformation. Quotations. Okay, you see, we have some articles with logarithmic transformation, which have done logarithmic transformation. Free article, M mode measurements and PV after logarithmic transformation of the data. So some articles, some scientific papers, they mention about, they present their data after logarithmic transformation. Okay, logarithmic transformation is frequently used in medicine. Then lastly, the weighted mean. What is the weighted mean? The weighted mean is about some certain values of interest might be more important than the others. This you have in some schools when they calculate the average mark at the end of the year. You have different weights of your topics. Let's say maths. You have how many hours per week? 10 hours per week. But literature, you have 5 hours per week. Then exercise or sports, you have, let's say, 2 hours per week. And then you receive some scores from these each of these topics. From math, let's say you got a 7 out of 10. From literature, you received a 6 out of 10. And from sports, you received a 10 out of 10. What is your final mark? Will it be adding these together? Will it be okay to adding and dividing? 10 plus 6 plus 7 is 16, 21. 21 divided by 3. Is this your mean? Is it okay to give this?
No.
No, of course not. Because maths, you had 10 hours per week. Therefore, this should have a higher weight. Therefore, what did they do? They have weight 1 multiplied by x1, weight 2 multiplied by x2, and so on, and divide by the total weight. So weight 1, 10, multiplied by 7 is 170, 70. 5 multiplied by 6, 2 multiplied by 10, divided by the total weight, which is here 10, 15, 17. And we have the total of the weights multiplied by the cases. So this gives us the weighted mean, and weighted mean is also frequently used in scientific articles, scientific work, scientific papers, because also in medicine, it is important, it is essential, it is crucial for us to adjust for some kind of weights. Just a last word to make it more understandable for you. We have the mortality figures, mortality, total mortality rate. Okay. What do you think is the total mortality rate for Kyrgyzstan?
$60 to $70.
Kyrgyzstan. Okay. Data UNICEF. UNICEF is good. 60, 70 is maybe too high. Where is the total mortality rate? Mortality. Under 5 mortality. I want the total mortality rate. Under 5 mortality, infant mortality. Total. Oh, it's not given here. The total mortality. Anyways, I will not waste my time. Let's say I give you the total mortality rate for Kyrgyzstan. Kyrgyzstan, and I tell you it is 5. This is usually given as per 1,000. 5 people out of 1,000 population will die in a year in Kyrgyzstan. And I give you the total for mortality rate for Germany. It is, I tell you, it is 8. 8 divided by 1,000. Okay. If I just mention you this naked figures, these naked figures, like in Kyrgyzstan, 1,000 of out of 1,000 people in the population, 5 are dying in a year. While in Germany, 1,000 out of 1,000 people, 8 are dying in a year. Could this be a misleading? Yes, it could be, because then you might start thinking, oh, in Germany, there are more people dying. Is it because of health inequalities maybe? Maybe in Kyrgyzstan, the hospitals, the health services are better compared to Germany. But we know that this is not true. The real reason behind this difference, why? Because Germany has a higher mortality rate, is what?
Maybe age.
Of course, age. It is the age. This country has a much higher mean age. So if you want to display your data, you should give it as weighted according to, you should give it as a weighted mean, weighted according to age. Okay? You understand what is the purpose of giving weighted? It is very important in medicine. We do it very, very frequently. Okay, so you should also have a look at this table, the advantages and disadvantages of mean. Especially, I will ask you in the exam about the mean and median, and you see there are some advantages and disadvantages. Please read this table and try to understand. If you don't understand, you can ask me or Dr. Azamat. Yeah, geometrical mean and weighted mean. Mode we don't use so frequently, but I will ask it in the exam probably. But it's not, in practice we don't use it. But geometrical mean, weighted mean, median, and mean, and arithmetic mean, these are very frequently used. We have also other types of means like the harmonical mean, but for this purpose, for the purpose of our class, these are enough. Okay, Dr. Azamat?
Yes.
Do you want me to shut up? Is it enough?
No.
Is it enough headache for the students?
I think it was a lot of information.
Nobody should be scared. Next session, next week, we will have a short repetition. But until then, take care. See you later.
Thank you.
Thank you, Mr. See you.
Bye-bye.